Okay, we have already discussed it last time. There's only one new term here. Okay, so we talked about scientific knowledge, right? What is empirical knowledge? What do we mean by empirical knowledge? We have empirical equations. Some equations are empirical, some equations are mathematical, and so on. Anybody knows the meaning of empirical? You don't know, right? Huh? So search for it. Why are you looking at my face? Search. Empirical. Who has an iPhone here? You? Search. You did? What's the answer? Huh? Concrete what? Concrete problem. Okay. Who has some other phone? Not iPhone. Huh? Yeah. Experience. What phone you have? iPhone? iPhone. Okay. Not other people who don't have iPhone. There's nobody like that. Yes. Your phone said that. You don't know your mind. Who needs a mind? Yes. People who don't have iPhone. Yes. So see, different phones are giving different answers. This is what I was trying to see. If you get different answers from different phones or not. Huh? You get it. Okay. So you are saying based on concrete problem. And you are saying what? Ashim? Experience. Okay. Good. Okay. So empirical knowledge is something you discover through experience. Okay. It may or may not have any theory behind it. Okay. It may or may not have any theory behind it. So for example, you may have seen this. Huh? What is F here? Force, right? And M is what? Mass. And A is what? Okay. Who gave this equation? Huh? I just give it to you. Who is Newton? Right. So there's a force, there's a mass. Okay. So if I give you these two parameters, you can calculate the third one, right? Okay. So this is based upon what actually happens. This is a natural law. Okay. This is a natural phenomena. This is how things move. Okay. This is how things move. The force needs to balance the mass and the acceleration. This is how the things will move. Okay. Clear? Okay. So this is a scientific equation. This is a scientific rule or law or kanun, as we say, right? Okay. But if I tell you this equation, force equals 1.3 times A. Now what is it 1.3? Why is it 1.3? Okay. Maybe I took a sample, okay, and I applied the force and saw the acceleration. And then I saw they are not equal. Okay. Why they are not equal, I don't know. Why they are not equal, I don't know. But force is always 30% more than acceleration, which is 1.3, right? Okay. So this I made the equation. I took two values and then I saw what will I put between them to make them equal. This is called as empirical. Okay. So in empirical equations, in empirical knowledge, and we use it a lot. In construction, we use it a lot. Okay. So in empirical knowledge and construction, you will see lot of numbers. You will see lot of numbers, and they may not have any equation behind them. Okay, they may not have any equation behind them. So somebody says, okay, when you are taking the dia of steel, it should be this much times the length of the steel. There is a rule. There is a rule, something which they follow in the construction industry. Now I forgot, obviously, in a long time. But there is a rule. Length should be this many times of the dia. It is written in the standards as well. It's not only what they are doing in the site. If you open the codes, American code, British codes, you will find these rules. Okay. For example, they may say the length should be 30 times of the dia of the steel. Why 30? Why not 29? Okay. What will happen if I do it 35 times of the dia? We don't know. Okay. So empirical is something which you try to fit. So I have a problem that, going back to the example of the steel, when I do it more than 30 times, there is too much deflection. Okay, when I keep it to 30, the deflection is reasonable. Okay, it's acceptable. So I came up with a number. Okay, 30 is good enough. More than 30 not good. Less than 30 is good. Okay, but if you ask me to give you the equation, don't have the equation. It's a rule. Okay, so empirical knowledge is something which you come up with by observing something. Experience, right? Somebody said experience. That experience is what? Observation. I observed this thing for 200 times. So now I know what happens. Okay, and this is how I mentioned earlier, the site supervisors who may not be engineers, but they have this knowledge more than you when you will go to the site, because what you are reading here is, books and equations and so on and so forth. Okay, so you are strong on that side, but those guys are strong on the empirical side. Okay, so that's why I said you still need to learn when you will go in the field. Okay. Okay, so a scientist tries to find out a new law or find out new information. Okay, and so here you see only scientific knowledge and scientific method, right? You don't see any empirical thing here, right? Empirical is part of engineering. Scientists cannot say, okay, just put 3 and it will solve everything. No, you have to give the reason. As a scientist, you have to give the reason. Engineers can do anything. If it works, nobody asks. Okay, if it is working, nobody asks. Okay. Okay, so they are developing new knowledge and we are trying to use it. Okay, so it's not like we are not using them or they are not useful for us. We did this exercise in the last lecture where you were telling me different courses, right? And many of those courses which you mentioned from science, you already took them. Okay, and they are part of your curriculum. Okay, so engineers design and provide products and services using the scientific laws and chemical laws and mathematical rules to give us these things which we use every day. Okay, so everything which you see around you, which you are using, is all part of engineering. Okay, so you see some points here. Okay, some of them were already mentioned earlier. Which one? Cost, reliability, safety. Okay, then we see 2 other things which are efficiency and sustainability, right? Okay, what is efficiency? I should know it, right? Efficiency is what? How do I calculate efficiency of something? There's an equation for efficiency, right? He is 100% efficient. My car is 80% efficient. What does it mean? How do we calculate efficiency? Yes. How do we calculate efficiency of a person or of a machine? Huh? Amount of product. So output. Only output. Output over the input. Efficiency is output over the input. Okay. Now what did we say our output is as engineers? We already mentioned the output, right? What is our output? This is a lot of output. Huh? Yes. What is our output as engineers? What do we provide to the society? I already mentioned the last slide, right? Or this slide, the last slide. What is our output? Huh? What do we give? Huh? What do we make as engineers? Yes. Buildings. Huh? Cars. Different products. Okay. Said buildings, is that different products? Anybody else? What do we make as engineers? Machines. Okay. Anything which is true for the benefit of the society, right? This is our product. Anything which is for the benefit of the society, which solves their problem, right? Okay. This is the output. And then we have to see the inputs. Okay, so we take the example of a building, because it suits us, right? When you are making a building, what are the things you need? Tell me. Huh? Concrete. What else? Huh? The land of the building? Yes. What else? So the land and concrete and what else? Huh? Labor? The worker, right? Worker, labor, you need people, okay. Anything else? Huh? Safety gear, okay. And anything else? Beam, okay. What else? Huh? Surveyors, okay. Okay, so you get the point, huh? You need material, you need land, you need people, right? These are three main things. Then you need one more thing. Land, people, material. One more thing. Very important. You mentioned it already. Yeah, you. Huh? Plants, you mean what? Plants or branch, no. Money? You need money, yes. You need money. So people, materials and land comes for free, then we need money, right? Yeah, what else? What do I do with the material? I just pick it up and put it somewhere. We need what? Test, okay. Equipment, yes. Equipment, yes. And yes, tests are also there and other things are also there, drawings and plans, everything is there, okay. This is the input and the output is the whole building, right? Okay. And then you use money to calculate the worth of the building, right? Okay. So all this is part of your efficiency. How much time and people and material and equipment you are putting into it, and what is the output you are getting. Okay. So if we have seen the construction of a villa, okay, like I don't know, the smallest size of villa you can imagine. Okay, how many months it takes? Construction of a villa, one villa. How many months? 9 months? 6 months? Okay, it depends. But it's a small villa. Should it take 5 years? So this is efficiency. Okay, this is efficiency in terms of time. And then you can calculate efficiency in terms of cost and so on. Okay, so efficiency. And what else? Then we have another new term which is sustainability. Okay, what is sustainability? Do we know? Yes or no? Do you know about it? Yes or no? Huh? Do we know about sustainability? You know? No. Let's search for it. Yeah. Sustainability, what does it mean? Huh? Durability, okay. It's a part of sustainability. Yes, what is sustainability? Anybody else? For the next, what is durability? Huh? Age of something? Maybe? People who are searching, what are you searching for? You start seeing your notifications, right? Huh? I ask you to search and you go to Instagram, right? Yeah, what is sustainability? What does it say? Okay. Sustainability, yes, is related to durability because if you make something sustainable, it should last longer. Okay. Yes, it's related to durability, but it doesn't mean then your efficiency is a problem. These two terms are related. Okay. So I make something which is very durable. It will last for next 100 years. But I am using material in it. For example, I am using plastic. Okay, so you know plastic, even if you just leave it, it will remain as it is for many years. Okay, but then it has its harmful effects. So something could be very durable, very long lasting, and it may not be sustainable. Okay, so sustainability means that you try to increase the environmental efficiency of your product. I told you, efficiency could be in terms of time, could be in terms of cost. Okay? Sustainability is efficiency in terms of environment. You make a very big project, but the environmental effect should be minimized. Okay? But at the same time, it doesn't mean that, okay, it has zero emissions, but it doesn't work as well. Like a car. Huh? So the car is not working. Does it take any fuel? No. Does it have any emissions? No. But it's not working, right? So sustainability means increasing the environmental efficiency of your product. Okay, and the rest of the things we have already discussed. Okay. Okay. This we already mentioned earlier. Okay. That, but somebody mentioned here. Once you design, then you have to do the check and balance to make sure your design is implemented properly. Okay. So there are tests for materials. There is inspection for your site. Okay. Quality inspection and so on and so forth. Okay. So doing inspection and doing testing is part of an engineer's job. Then we have innovation. So engineer does not only rely on existing solutions. When he looks at the problem, I told you earlier, some problems may not be solved by whatever you are doing right now. And I give the example of the automated car, right? So the normal car has problems and cannot be solved without having an automated car. Okay, so somebody thought about the problem and then he gave a new solution which was not available at that time. Okay, so looking at, so you try to improve on the existing resources and as well as try to come up with new solutions to the existing problems. Okay, so it is your job to design, it is your job to check the design, it is your job to improve the design, and it is your job to look for something new which can be better than the design, better than the current design you have. So these are 4 areas for engineers, main areas: design, check, improve, and innovation, new, something new. Clear? I know. You came late. Did I do this?
No.
What is it? Not at least you. Okay, somebody who was already here waiting for me, he can do it, or she can do it. Not you. The guy who came with us. Okay, clear?